Okay, welcome to the 10th lesson in networks. We are now definitely getting to the nitty gritty and you need to fasten your seatbelts. This is probably going to be a bit of a bumpy ride. We're looking now, we're heading towards protocols and layers, and really what this is about is how we transmit data and how we build the data to transmit around a network. So in this lesson, I'm going to give you sort of the standards that we're looking at, and a couple of the standards that I'm going to show you is something called packet switching or circuit switching. The point is we need standards because computers are the same all the way around the world, and if we don't have a set of standards, then computers won't be able to talk to one another. So we're going to take a look at how it happens, and hopefully we're going to put some sort of meat on the bones of what we've been doing up till now. So I've got on the screen here in a bubble a bunch of computers all linked together. This looks like a mesh. Don't worry too much about what the actual network is inside, but the point is that all the computers inside that bubble all belong to a local area network, and I have a wire coming out which is going to attach to the wide area network, the WAN, for communication. But to do that, we're going to need a router on the outside of the LAN. Inside, I've got in red something called frames. The way data is transmitted around the network is by using a technique known as frames, a standard known as frames. And I will explain that just after I've gone through everything about how to put a packet together, so that you might be able to understand frames a little better. So here we go. Let's think of having loads of networks around the world. Each little bubble here is a local area network, a LAN, and they're all connected to a router. And the router is on the outside of the LAN, but hasn't yet connected to the actual wide area network, the WAN. So the local area network only connects to the router, and the router's job is to pass data around a network, the internet you might think of, to get information from different networks. So here is our wide area network. This is the internet. So all the routers are connected to one another. So if you take a look at it, they're all connected to one another, and that is a mesh. If they weren't all connected to one another, it would be a partial mesh. It doesn't really matter. But the point is that we've got the red lines on the outside connecting to one side of a router. On the other side of the router, we've got the local area network. So one side is the WAN, one side is the LAN. Now, the way data is transmitted around it is in things called packets. So we've just seen data which could be transmitted around a LAN, and they're called frames. But if we're on the internet, we use an internet protocol, IP, and we use packets to send. So packets only exist on the internet, on a wide area network. Frames only exist in a local area network. So let's take a look at a little bit more about these networks and how they operate. So we've seen that networks can have IP addresses. So let's take a look at this LAN over here. I've got network addresses all start with 192, then 168, then .0, and then at the end I've got a computer number. Number 4, number 5, number 20, number 12, number 10. But they all have 192, 168, 0. That is the sort of local area network. And every LAN can have exactly the same. So if I move across to this LAN over here, it starts off with 192.168.0.14, and the two red ones are number 4 and number 5. They are exactly the same numbers as over here. Now, IP addresses are supposed to be unique, but they are unique on the internet, but they are not unique in LAN. So two different LANs can have the same IP addresses. They're just not connected to one another. They have to go through a router first. And that is one reason as well why we need MAC addressing, which I will discuss a little bit later. So we've got IP addresses. They can be the same in LANs. They can't be the same on the internet. They must be different. So here, all my routers have got on one side of them, on the LAN side, an address 192.168.0.1, and every single router that I've got has the same IP address. Now, that's probably not correct in the real world, but for our demonstration, that's okay. On the other side, on the internet side, I've got in red, it's public IP. So the 192.168.0.1 is called the private IP, and these are private IP addresses. The red ones are public. They're open to the internet. They're seen by everybody in the world. And notice that the numbers can start with different values depending on the network. So the number might indicate what country, what network it is, etc. But we have two sides of a router. We have the public side, so this one is 67.222, and we have the private side, 192.168.0.1. So a router really has two IP addresses, one on public, one on private. Now, this is the internet, and so I've put my locations for the different IP address, public IP addresses, in different locations around the world. So this one's for London, this router here is for Cardiff, this one's for New York, so there's a sort of small LAN in a company in New York, this is a small LAN in a company in Rio, this is a small LAN in a company in Paris, and so on. So this is global, the internet, the wide area network. It goes between major cities. This is local. This is probably just the school or a school in Cardiff or a home in Cardiff with their IP addresses. So we've got public in red here and private in black over here. So if we want to send a message from London to New York, and the message is hello world, and I've written it on the screen in exactly that, capital H, capital W, and there's a space between the O and the W. I want to send that message from London to New York. I need to know one or two things, and I need to send it in something called packets because it's going on the internet. It's going to use IP addresses, internet protocol. Protocol means rules. So we're using the internet rules to send the message from London to New York. So we need to break this message up. Oh dear. I can see this is going to be a nightmare. I'm not stopping to redo it. I think when the video plays, the actual width of some of the text boxes shrinks. Never mind, you get the idea. So I need to divide this message into packets, and a packet consists of a header, and I've got that on the right hand side there, the payload, which is the actual message or the data that we wish to send, and a trailer, an end bit. So there's 3 bits to a packet. This is a packet. So I'm going to show you how we build the packet up. So I'm going to take a look at the payload. The payload is split up. Now, hello world can't be split up too much. Normally we've got a lot of data, so that would be split up a lot more. But I have split this up. So the first packet is going to contain HELL for hello. Then the second packet is going to contain the O, the space, the W and the O. And the third packet is going to contain just the L and the D. So I've broken my payload up into 3 pieces. So now that I've broken up my message and I've got 3 bits for my payload, I'm going to build the headers. So the headers contain certain information. And the information it contains is, for a start off, the packet number. So this is the first packet, so it's called number 1. Second packet, so it's called number 2. Third packet, it's called number 3. And then I've got 2 IP addresses. One is the sender, and if we go back and have a look, one of these is London and one of these is New York. So the top one there, 96.129.44.3 is London, 95.12.4.99 is New York, and that is put in each of the packets. The next number down is, well, how big is the packet size? Now, all I've done is just counted up the letters for the payload. This is not for real. It would be rather a large number. It'd be pointless explaining how that's built anyway. So I've just used the number of letters to just say that we've got a packet size, and the packet size here is 4. The packet size here is 5. I know there's 4 letters there, but we've got a space. So 1, 2, 3, 4, 5. So the packet size is 5, and this packet size is 2. So we've got a packet number, the sender, the receiver, and how big the packet is. And the next one down is what is the protocol that we are sending. Now there's quite a few protocols, and we are not dealing with them just yet. We'll deal with them in the next lesson. But this one is called the Internet Protocol, Transmission Control Protocol, Internet Protocol. That's what TCP IP stands for, and it just means it's a browser. It's going to send information to a browser or be read by a browser. So that's the header, the packet number, the destination and sender, the size of the packet, and the protocol. And this is a simplified version of it all. Next, we look at the payload. And these letters are going to help us when we come to figure out whether the message is correct or not. In the trailer, we are going to include what we call a check, an error checksum, which is going to tell us whether the message was received correctly or not. So I'm going to show you a way of doing that, one way of doing it, and maybe loads of different ways, but a good idea of what's going to appear in the trailer. So first of all, I'm going to get the ASCII table. And for all the letters, I'm going to look up the decimal number of all the letters. So here I've got H, capital H, which is 72, lowercase e, which is 101, and then L, which is 108, and so on. So I'm finding all the decimal numbers for the characters of Hello World. And what I'm going to do is I'm going to use these decimal numbers by adding them together to form a check on whether the data was received correctly or not at the other end. So how does that work? Well, here's my packet again with HELL and my header. And what I do is take the 4 letters, HELL and the capital H, I find their decimal number and I add them all together to get the value 389. I do the same for O space WOR, add them all together and I get the value 455. And I do the L and the D, add them together and I get the value 208. Now, if I send that in my packet as part of the trailer, so 389 tells me that that should correspond to the characters HELL. So when it's received in New York and they look at the data, they will do exactly the same thing. They will add up these, the value for each one of these letters, which again is a standard. The ASCII table stands for American Standard Code for Information Interchange. So that's another standard that the two computers need to use. But it will add up the numbers, and if it gets a different value to 389, it knows that an error has occurred, and it will look up who the sender was and will send a message back saying, excuse me, can you send me this piece of data again, please? That package was sort of broken and I need a decent one. So the trailer contains some error checking, and I've used a checksum here. There's other methods of doing it as well, but we're not interested in that just at the moment on the course. The very last packet, number 3, also has a kind of end of packet notification, so we know that this is the last packet. So if the receiver only gets packet 1 and 2 and doesn't get the last packet, it's going to send again back to the person who sent it and say, I haven't received all the packets. But we need to have a look at how the information is sent around the internet now, and that's the purpose of packet switching, how we send this information around. So here we've got London, going to send to New York, and here's my router. So some computer on here has made the message hello world. It's been split into 3 packets. So it sends the data. Now, packet switching means it does not have any direct connection. Here is the direct connection to New York. It would be nice and easy to send it that way. But if there's some data already on this line, it will find another path to New York. So let's imagine that there's some data already on here and it says I can't send it directly, so I'm going to send it to this place here. I can't remember if that was Rio or not, somewhere else in the world. So packet 1 is sent to this router here. And at the moment, New York, down the bottom, has got no data coming through. So then it's going to send the second packet. Now, as it sends the second packet, this router here forwards the packet on to the next one. It could have sent it directly to New York, but I'm going to assume there was some data on there already. So it sends it yet again. I think this one is Rio. Sends it, yeah, this one was Paris. This one is Rio. So it sends it now to Rio de Janeiro in Brazil. So packet 1 is heading off to Brazil, and packet 2, this line is now cleared, so it's going straight to New York, and New York receives packet 2 first. Packet 1 is still in the network. Packet 2 has arrived at New York. So we now send packet 3. And packet 1 still can't send it to New York, so it sent it to Cardiff. And packet 3 obviously can't get directly to New York, so it's also sending it to Cardiff. And New York at the moment has just got packet 2, and it's still waiting for the rest of the packets to arrive. So a little bit further on, packet 3 directly to New York. So New York has now got packet 3. So it had packet 2, now it's got packet 3, but packet 1 is going back off to a place that it's already been, to Paris. So packet 1 still hasn't arrived at New York. And finally, packet 1 goes from Paris to New York, and New York receives all the 3 packets. Now, when it received packet 3, it also received the message that this was the last packet. So it knows there are 3 packets. So it's now waiting for the 3rd packet to arrive. Packet 1 is the 3rd packet to arrive out of the 3. So now New York knows it has all of the packets. And what it does with those packets is puts them into order. So it reassembles the message. So packet 1 goes first, packet 2 goes second, packet 3 goes third, now that it knows how many packets it's got and it's received them all. So New York now has the message that we sent. So that was packet switching. Now the point of packet switching was that in the header it sent an IP address because it went on the wide area network, on the internet. But if we are on a LAN, we're going to use the Ethernet. That's another word for LAN, really. And I said that we were going to use something called frames. Frames are exactly the same as packets. They contain a checksum, they contain the payload, and they contain a header. But the difference in the header is that it now, instead of having an IP address, which on the LAN, it could be anything. Remember, IP addresses are handed out randomly. So the lease expires. So if when you started off sending the message, you had number 4 for your computer, and then your lease expired and became number 5, then the IP address would not be very reliable. So it uses MAC addresses to know which device it needs to send the information to. So the difference between packets or packet switching and Ethernet frames is the fact that frames have device numbers, MAC addresses, rather than IP addresses. So the only thing I've changed here is the 2 MAC addresses from IP addresses. That's the point of frames, is that they go directly to the computer, whereas on the WAN we need IP addresses. So the router really is responsible for doing all of this jiggling and messing about. Let's break down what we've done. So if we send data over a network, we need to break it down into packets. And that's handled by software. And we're going to see that in a couple of lessons' time when we look at layers. And they normally contain 3 bits. The header, that contains the IP address of the sender, and also the IP address of the receiver. It contains the packet number. It contains the length of the packet and also the protocol that it's using. Now, watching or viewing a web page, that's called TCP/IP. But if you were to get mail, that's a different protocol altogether. Or if you were transferring a file, that's another protocol, and we'll look at those in the next lesson. Secondly, we have the payload, which is the actual data we're trying to send across. Thirdly, we have the trailer, which contains whether it's the end of packet, whether it's the end of the message, a marker, and some form of error checking, whether it be checksum or other kind of message. You don't really need to worry too much at the moment about error checking. We'll deal with that on the theory side a little bit later on. But it could be anything really. It just depends on how the computers are sort of communicating with one another. So when the data has been divided into its packets, it can be sent across a network. That is called switching. Now, there are 2 versions of switching. One is called packet switching, and there's another one called circuit switching, which I will have a look at in the next slide. The difference between the 2 is that in a packet switching network, every packet can find its own route to its destination, as I showed. It doesn't need to go straight to New York. It could go to Paris, then Rio, then Brazil, then wherever. It can go all the way around the world many times if necessary in packet switching. So the reason for that is, as we saw in mesh networks, if a router breaks or goes down or a computer goes down, the router can actually send a message to a different place. When all the packets have arrived at the receiver, then they can be reassembled and the message can be read. If it doesn't receive all the packets after a certain time, it will ask for them again. If there is an error on one of the packets, it will ask for it again. There's lots of checking that goes on. These are standards that each computer has to follow. They have to know what, they have to be working the same. They have to have the same standard, otherwise we won't be able to communicate. So that's packet switching, where it can find its own route. The difference between that and circuit switching is that in circuit switching, the 2 computers talk directly to one another. And what they do is they first of all talk to one another, say, are you ready to have a message? Yeah, I'm ready to have a message. Are you going to send it? Yeah. How are we going to do it? Oh, I think I'm going to send 10 bits in my packet. Okay, I'll accept 10 bits. So they communicate with one another to establish a set of rules that the two computers, and only the two computers, agree to. And that is called handshake. And then once that's happened, they can build their packets in software through the layers, which I'll explain in a couple of lessons' time, and they just stream it between the two. It doesn't go everywhere. It goes directly from one computer to the next. So, in brief, that is how data is transmitted across a network, both using the WAN and the LAN. Good luck.